Today we're going to talk about lesson 5 in chapter 10 for math and chapter 15 for advanced math, which is on independent and dependent events. Compound or two or more events may be independent or dependent events. Events are independent if the occurrence of one does not affect the likelihood that the other event will occur. So these are two completely separate things. They do not rely on each other. So the probability of independent events can be found by multiplying the probabilities of each event together. So for instance, what is the probability of spinning a multiple of 2 and flipping heads? So we're going to write that as the probability of a multiple of 2 and flipping heads. Now, when we look at this, the probability of spinning a multiple of 2, well, we know that that's either going to be a 2 or a 4. So that's 2 out of 5 times the probability of flipping a head. So we know one side is head and one is tail, so that's 1 out of 2. Multiplying the fraction straight across the top and straight across the bottom, 2 times 1 is 2, 5 times 2 is 10. We can then reduce to know that our probability of a multiple of 2 and heads is 1/5 or 20%. Events are dependent events if the occurrence of one event does affect the likelihood that the other event will occur. The probability of two dependent events, A and B, is the probability of A times the probability of B after A has already happened. So here in this example, people are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So that was the example, but now we're going to do the on your own. So you can go back to your book and look for this example if you'd like. Now, choosing an audience member changes the number of audience members left. So the events are dependent because we're already taking some people out and we're not putting them back. So here, what is the probability that you, your relatives, and your friends are not chosen to be either of the first two contestants? So we have you, 5 relatives, and 6 friends. So 1, 5, and 6 makes 12. But we need are not chosen out of 100 people. So how many are left? Well, we know that 100 take away 12 is 88. So there are 88 people that are not one of those people. So this is 88 of 100. So this would be the probability of not and the probability of not, because you're not choosing any of those people listed. So the first time would be 88 out of 100. 88 of those people out of the 100 people in the audience would satisfy this. Now, for the next time, they've chosen one of these people that are not one of your family friends. So if there were 88 of people that were not in that category before, and they've chosen one of those, now we have 87 people to choose from the audience. Now, 87 of the people in the audience would fit this not friends, family, or yourself. Then total number of audience members went from 100 to 99 because we've already chosen an audience member. Now, you can simplify and then multiply, or you can multiply and simplify, it doesn't matter. 88 and 99 are both divisible by 11. So 8 times 87 is 696, and 100 times 9 is 900. Now I know that these are both divisible by 3, so 232 out of 300, and those are both even numbers. So I can divide each of those by 2 again to get 116 out of 150, and then 58 out of 75. So 58 out of 75 would be my probability for this problem. So remember that the numbers are going to change because we're already taking options out of the pool. Now, a student randomly guesses the answer for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? So here, the first one, we had a 1 in 5 chance. The second one, we had a 1 in 5 chance. The third one, we have a 1 in 5 chance. So multiplying straight across the top and straight across the bottom tells us that this student would have a 1 in 125 chance of getting all 3 questions correct. So that's not that great. But now let's see what happens here in number 3. The student can eliminate choice A from all 3 questions. What is the probability of answering all these 3 questions correctly? Compare this with the number that we arrived before. So if we take choice A out of all 3 of these, we have 4 choices left. So this would be 1/4 times 1/4 times 1/4. So 1 times 1 times 1, 4 times 4 times 4. Now we have 1 in 64 chances that we would get this correct. What we notice is that our odds almost double. So we're almost twice as likely to get all 3 answers to correct those questions based on taking one option out. You can see here that if you apply this to a situation that you might see, even by knowing some of the information, you're better off than not knowing any of the information, because you can help reduce your options, which will increase your odds in getting the answer correct.